Another thing that we need to review as we move into more discussion about probability is how to deal with fractions. In the past, we've just converted fractions into decimals, but sometimes it's better to just leave our answers as fractions. And so we just need to get used to working with fractions when it comes time to add two probabilities together or subtract two probabilities from one another, or whatever the case may be. We already talked about reducing fractions a little bit in the context of changing them into decimals, and we'll just use our calculators to do these reductions. You can reduce by hand if you want to, but you're also welcome to just use a calculator. We've seen this diagram before, but just to show you why 10 hundredths is the same as 1/10, you can imagine taking a square and dividing it into 100 parts and shading in 10 of them. And the overall area that you end up shading is going to be equal to the area if you had taken that square and split it into 10 parts and shaded in one of those parts. So 10 hundredths is the same as 1/10. Now, the way that we get that answer by hand is by dividing both the numerator and the denominator by 10 in this case. More generally, we would reduce any fraction whose numerator and denominator have a common factor by dividing out that common factor. Okay? The Desmos calculator will do these reductions for us, but let's just practice. So let's say that I have the fraction 8/12. If I wanted to reduce this by hand, I would think to myself, what's the largest number that multiplies into 8 and 12 without any remainder? And the answer would be 4, right? 4 goes into 8 twice, and it goes into 12 3 times. So I can divide each of those numbers by 4, and this reduces to 2/3. Okay, checking that in Desmos, right? 8 divided by 12. Now, it does give me a decimal as my answer, but remember that I can press this button here and change it back to a fraction, and sure enough, it gives me the reduced fraction as 2/3. 10/12 would be similar. I think the largest number that multiplies into both of those without remainder is 2, right? So I can divide out a 2 and end up with 5/6. Here I think it would be 15. 15 goes into 45 3 times, and it goes into 64 times. And here, this is already in lowest terms. This will not reduce any further. There is no number that goes into both 13 and 17 without remainder. And you can check all of these, right? 45 out of 60, right, is 3/4, and 13/17 does not reduce. Okay? All right. Now, if we want to multiply fractions, that's really easy. We don't need a common denominator or anything like that. To multiply fractions, we just multiply straight across, numerators with numerators and denominators with denominators. If we type this in exactly the way it looks on our page into the Desmos calculator, then we'll be safe. So let's practice. If I had something like 4/5 times 4/5, if I wanted to do it by hand, I would just multiply straight across. 4 times 4 is 16, and 5 times 5 is 25, so this should be 16/25. If I do that in Desmos, I would do 4/5, arrow over, and then say times another 4/5, and it's giving me the answer as a decimal, but I can change it into a fraction. Sure enough, 16/25. Okay. If I want to do 4/5 times 3/4, 4 times 3 is 12, and 5 times 4 is 20. And then I notice that that reduces. I can divide each of those numbers by 4 without remainder. So this should be equivalent to 3/5. 12 divided by 4 is 3. 20 divided by 4 is 5. For something like 10 23rds and 7 15ths, you might notice that it's easier to do the reducing before you do the multiplication, and that's called cross-canceling. Or if you're not familiar with cross-canceling, don't worry about it. But I noticed that a 5 will go into the 10 twice, and it'll go into the 15 3 times. And now this makes my multiplication much easier because I can just do 2 times 7 to get 14, and 23 times 3 to get 69. Again, if all of this is too much for you, then feel free to use the calculator. 10 23rds times 7 15ths, and change it into a fraction, and sure enough, that's 14 69ths. So that's how multiplication works. For addition and subtraction, we do need a common denominator. We have to have a common denominator in order to add and subtract fractions. The bad news is that it takes some work and practice to learn how to find common denominators. The good news is that most of the fractions we're working with are already going to have common denominators, and you'll see why as we get into the probability sections that we're going to be covering, but we're pretty much going to have common denominators already. So I'm not going to take any time practicing trying to find common denominators. And in the off chance that we do have to add two fractions with uncommon denominators, we'll just use the calculator, okay? But when you have a common denominator and you want to add or subtract the two fractions, you just add or subtract the numerators and you leave the denominator unchanged. This might seem a little bit strange, but it's helpful if you read it out loud, right? For example, 1/3 plus 1/3 should be 2/3, just like 1 apple plus 1 apple is 2 apples, right? 1/3 plus 1/3 should be 2/3. And that's why we're not going to change the denominator, we're going to leave it the same. One thing to warn you of is that we shouldn't round too early, and this is why we're practicing dealing with fractions rather than just converting them to decimals all the time. Because if you round too early, you could end up with errors. And the 1/3 plus 1/3 is a good example of that, right? So if I do 1/3 plus 1/3, I know that that should equal 2/3, and 2/3 rounded to 3 decimal places would be 0.667. But if I round too soon, if I round 1/3 to a decimal, I'll get 0.333. And so 1/3 plus 1/3 would be approximately 0.333 plus 0.333. And when I add those up, I get 0.666. And you'll notice that I've already introduced some rounding errors into my answer, which is bad news. So generally speaking, we want to save any rounding for the last step of our calculation. We don't want to do any rounding prior to the last step of our calculation, which means when we're dealing with fractions, with adding and subtracting and multiplying, we don't want to change them into decimals first and then do the multiplication or addition. We want to do the multiplication or addition first and then change into a decimal. Okay, with all that said, again, if you're using the decimals calculator, it'll perform the calculation correctly. But let's just practice doing some by hand, and we'll check our work with a calculator. So 3/10 plus 5/10, for example, would just be, well, 3 plus 5 is 8, so this would be 8/10. And if I want to reduce that, I notice that a 2 will go into both of those. So this whole thing reduces by 2 to 4/5. And you can check that with a calculator in Desmos. I'm not going to waste your time checking it. 17/36 minus 6/36 would just be 11/36. And that one does not reduce. That's as far as it goes. 16 out of 52 plus 7 out of 52 minus 5 out of 52. Well, 16 plus 7 would be 23. And 23 minus 5 would be 18. So this should be 18 out of 52. And that will reduce by at least 2. 2 goes into 18 9 times, and 2 goes into 52 26 times, and that's as far as that one will go. Again, you're welcome to check any of these on your calculator. Last thing that I want to talk about is how to, we're going to encounter some formulas when we do probability. And so let's practice plugging fractions and decimals into probability formulas. So suppose that probability of A and B equals probability of A times probability of B. That's what all these symbols, that's how we would read these symbols. And we'll talk about that in the stats course, okay? But we'll use the given values of probability of A and probability of B to calculate the probability of A and B, okay? And I understand that you may not understand what I'm even talking about, but that's okay. We can still plug numbers into a formula, right? So probability of A and B we're told is probability of A times probability of B. We're also told that probability of A is 0.3275 and that probability of B is 0.2788. So all I'm going to end up doing is 0.3275 times 0.2788 in my calculator. And that comes out to 0.0913-ish. Maybe I'll say, we rounded, right? So we'll say it's approximately 0.0913. Same thing goes if you're trying to punch in fractions, right? Again, we're told that probability of A and B is probability of A times probability of B. The probability of A is 2/5 and the probability of B is 1/3. And I can type that into my calculator, but this should just be 2/15. Okay, so that's how that works. It's also the case that probability of A or B is the probability of A plus the probability of B under certain circumstances. So let's calculate the probability of A or B. If we know that the probability of A is 0.3275 and the probability of B is 0.2788. Okay, we know that probability of A or B is probability of A plus probability of B, which in this case is going to be 0.3275 plus 0.2788. So I can type those into my calculator, 0.3275 plus 0.2788. And there we go. And this would work the same way if I had fractions, right? Probability of A or B is probability of A plus probability of B. If probability of A is 3/10, then we'll just replace that with a 3/10, and we'll replace the probability of B with 4/10, and that will just come out to 7/10. Okay, and that's all there is to it. So we'll be dealing with these kinds of formulas. Let me give you just a couple more, and then we'll be done with this review. We're told to suppose that the probability of A and B is the probability of A times the probability of B given A. That's how we would read that symbol. We're also told that the probability of A is 2/3, and that the probability of B given A is 9/11, and we're asked to calculate the probability of A and B. So this is similar to before. One thing that I should point out is this symbol may seem really complicated. It may seem like there are actually 3 different variables here or something like that, but there aren't. This is just one symbol for one concept, and it's equal to this number. So we can replace this entire symbol with just this number. Okay, so probability of A and B is probability of A times probability of B given A. We were told that probability of A is 2/3. We were told that probability of B given A was 9/11. And that's it, right? You punch that into your calculator, and you get the answer. This is going to come out to, if I cross cancel, this is going to come out to 6/11. Okay. And one more. Suppose that probability of A or B is probability of A plus probability of B minus probability of A and B. And then we're given probability of A, probability of B, probability of A and B, and we're asked to calculate probability of A or B. So here we go. Probability of A or B is probability of A plus probability of B minus probability of A and B. Probability of A is 5/12. Probability of B is 7/12. Probability of A and B is 3/12. 5 plus 7 is 12. Minus 3 is 9. So this comes out to 9/12. And we can reduce that, right? 9/12 reduces by 3 to just 3/4. And that's that. Again, you're welcome to use your calculator on any of this. And that's pretty much what we will need to know in order to deal with fractions and formulas for the probability section of this course.